Where we left off in class today, we are finding the percent of monthly expenses in this here example 3. We're going to use our same 3-step approach once again. Step 1, we write a verbal model. Step 2, we identify our knowns and unknowns, which is actually the step that we do first in class. And then step 3, we're going to write and solve an equation using complete sentences. So here we have our family's annual income is $57,000 a year. And the following monthly expenses are what they have. Their mortgage is $1,100. The car payment is $375. Food costs $295 for the month, and utilities is also $240 for the month. Then we have credit cards, that's $220 a month. It says the total value of the monthly expenses represents what percent of your family's annual income. So we're supposed to figure out the percentage on a monthly basis of our expenses for the annual income. So we're going to go ahead and get started with that. The first thing I like to do, of course, just like we did in class today, was to identify what we know and what we don't. So I see a bunch of expenses listed there at the very beginning of the problem. Expenses. And then I also see that we have an annual income to help us pay these expenses. The annual income is definitely something that we know. That's going to be $57,000 annually. The expenses, however, are grouped out per month. So we know that if we want to find the total monthly expenses, we could just add $1,100 to $375 to $295 to $240, and then let's not forget about our credit cards, $220. So the sum for our monthly expenses is $2,230. So I know my monthly expenses, my annual salary, and then what I don't know right now is the percent of income that these expenses take up. So I'm actually going to go ahead and call that X. It's helpful before I get started to directly compare these two things, however. I have annual income and monthly expenses. Well, if you want to compare those things, you kind of need to compare, sort of apples to apples. In other words, I could calculate what these expenses would total up on an annual basis by multiplying them by 12, or I could take my annual income and figure out what I receive on a monthly basis. And that's kind of the route I took in order to compute what I called my monthly income. I need to be able to compare. If I want a percentage, I need to keep the units the same. I need to compare, like I said before, kind of apples to apples, months to months or years to years. It doesn't matter how you do it, but you have to keep it in the same unit. So our monthly income actually works out to be like 57,000 divided by 12, because there's 12 months in a year. I got $4,750 for the year. So then I went ahead and I wrote a verbal model. If I want to know what percent of the family income my expenses take up, it's safe to say that my expenses will equal a percent of my monthly income. So this is how I'm writing my verbal model. So my monthly expenses, no less, will be a percent of my monthly income. Hopefully it's not like more than 100%, because then, well, hey, my expenses are more than I make. And, that's a recipe for disaster. So with that, I can go ahead and use this verbal model to write an equation. So the first block I see here is my total monthly expenses. And my monthly expenses in this case totaled up to $2,000. $230. And we're trying to figure out the percent X that is of my monthly income. Of in math class, again, means to multiply. So that's why I swapped that out for a multiplication symbol. And then to figure out the percent, well, hey, we just divide both sides by 4,750. So my percent is going to be established by dividing 2,230 by 4,750. And when I worked that out, I got about 0.47. So we could translate that to be 47%, which is really good. They're living well within their means if they're not even spending half of their income each month. So we could say that to answer the question in a complete sentence, we could say it says what percent of your family's annual income is utilized on expenses. We could say we used 47% of our income to pay our monthly expenses. Me circling my final answer there for you. Okay, so that's example 3. And we just have 2 more, and then you have some independent practice that we'll talk about in a few. Okay, example 4, it says find the dimensions of a room. And you'll see that I'm inserting a step above our 3-step process because sometimes it's just easy to draw a picture. And what we have here is a rectangular kitchen, happens to be twice as long as it is wide, and its perimeter is 84 feet. We're supposed to find the dimensions of the kitchen. So what we're going to go ahead and do right now is draw a picture. It's a rectangular kitchen. So I'm going to draw a rectangle. And what they say there is that this kitchen is twice as long as it is wide. So I'm going to label my length and my width right now. For instance, I know that any width of a rectangle is usually the short side, and then the long side is usually what we call the length. Well, if it's twice as long as it is wide, it's often that we could call width W. And if it's twice that length, you know, if the length of it is twice as long as it is wide, that means that our length has to be 2 of these W's. We're ultimately asked to find the dimensions of the kitchen. They're also giving us some information about perimeter in the problem. So in step 2, what I'm going to go ahead and figure out is what I know and what I don't. For instance, I now know that the length, just from my picture there and in reading the problem, my length has to be 2W. And my width is now W. They're also telling me that big P perimeter is 84 feet. And in case you forgot what perimeter was, perimeter, quite frankly, is just the distance around the kitchen. So right there, that rectangle that I just traced in highlighter. So we're trying to, or what we're given rather, is that that thing that I just highlighted in yellow totally adds up to 84 feet. More commonly, we do have a formula for perimeter. It's common that we'll say perimeter is actually 2 of the lengths plus 2 of the widths, which actually leads us ever so nicely into our verbal model. Before we do that, what we don't know in the problem has already been kind of clarified. We have some variables in the problem. So as far as listing out everything that we know and everything that we don't, this kind of sums it up here. So we know that our length is 2W, our width is going to be W, the perimeter is 84 feet, and then we have 2 lengths and 2 widths put together to make the perimeter. So our verbal model is just that the perimeter, or the distance around the object, is equal to 2 lengths and 2 widths. You have to have, for a perimeter, 2 lengths and 2 widths. So in this last example, or in this last step rather, we can go ahead and just take a minute to use our verbal model to write a formula. So if we know that perimeter is 2 lengths and 2 widths, we're going to do a little substitution. We just said that a length is 2W. So what I'm going to go ahead and do, where I see the length, I'm going to put in 2W. And we just said our width was W. So where I see the width, I'm going to put W there. W. And then I bring down the rest of the formula sort of around the problem. P. We know what P is too, don't we? We know P is actually 84 feet. So I could substitute that in as well. So P is going to come down as 84 feet. All right, now what I'm going to go ahead and do is bring down the rest of my equation. So I bring down my equal sign, got to bring down my 2, got to bring down my plus, got to bring down my other 2. And now it's a good old equation like you might have had on your quiz. On your quiz, you know, we execute a 3-step process when we're trying to solve for a variable. So it's like we have 3 steps inside our 3 steps today. Woohoo! So you got to simplify the left and right side of the equal sign. This 84 stays put. 2 times 2W. That's 4W. And 2 times W is just 2W. And then I have like terms there. So I have 84 equals 6W. And then if I want to go ahead and solve that for W, I divide both sides by 6. So the width, or W in this case, ends up being 14 feet. But we're not done yet because it says, what are the dimensions of the kitchen? So we also have to find the length. We know that the length was actually just 2 of these W's. So I could take my value for W and sub it in. If my width was 14 feet, I can replace W with 14. And so you get 28 feet for your length. We write that as a sentence. You could say the width of the kitchen is going to be 14 feet and the length of the kitchen is 28 feet. So you want to make sure you include your sentence. If you need to pause now to write that out, it's not a bad idea. You could just hit your space bar and that'll do it for you. So we write our answers as a sentence. Next example here, we're going to estimate some travel time. It says a plane is flying nonstop from Portland, Oregon to Atlanta, Georgia. The distance between the 2 cities is about 2,170 miles. After 3 hours in the air, the plane flies over Topeka, Kansas, which is a distance of about 1,440 miles from Portland. It says, assuming the plane flies at a constant speed, how long will the entire trip take? And they give us a hint, which is super helpful. We know that the distance is going to equal the rate times the time. So there's a bunch of things that I'm going to go ahead and write about in this problem with regards to information that they give you. For instance, we know that the total distance for the trip is 2,170 miles. We also know that the distance from Portland to Topeka is 1,440 miles. They cover this distance in just 3 hours. What I don't know about the problem right now is the time it's going to take from Portland to Atlanta. To write my verbal model, I'm going to use their hint. Distance is going to equal rate times time. Well, if I want to find the total distance, I can actually find the product of the rate, or velocity at which it took me to fly from Portland to Topeka, and then multiply that times the time that it would take me to get from Portland to Atlanta. So I can use this distance equals rate times time idea in order to help me to figure out the time of my total trip. So I'm going to use the rate, but I'm going to steal the rate. I'm going to steal the rate from the distance from Portland to Topeka. So I'm going to do a separate little calculation to figure that out. So what I guess I need to find or list out in my knowns and unknowns is essentially, what is the rate of speed from which I traveled from basically Portland to Topeka. From P is Portland, T is Topeka. If I can establish that rate from Portland to Topeka, that's going to be the same rate from Portland to Atlanta. So that's really, really helpful. That's going to stay constant in the problem. To establish rate, basically I have to do miles per hour. And it says I travel 1,440 miles in 3 hours. So that's this value right there, kind of used to help me out. Which means this plane is traveling relatively quickly. This train is actually traveling at a rate of about 480 miles per hour when you calculate that out. So now I can use my verbal model to write the equation. It says, hey, take your total distance, which is actually 2,170 miles. Set that equal to my rate from Portland to Topeka, which is, we just actually did that little calculation right there. So this will be my rate. So that'll equal 480. And I don't know what time is. So we call the time from Portland to Atlanta. We don't know what that is. That's one of our unknowns. I don't know what that is. That's going to be our time. So I'll call that time T. We could then go ahead and just solve for this time really easily by just dividing both sides by 480. So the time it's going to take us to travel from Portland to Atlanta is going to be about 4.5 hours when I divided that out. Pretty good flight. Okay, so now you get to practice. You're going to go ahead and press pause right now. I'm going to go ahead and post some answers to this particular set of problems, and then we can use this as a warm-up to talk about tomorrow, and then we'll do more problems together as a class. So yeah, you can go ahead and hit your space bar. You're going to want to pause, work out these 3 problems, and then yeah, come with questions tomorrow to class. We're going to do another day of this again tomorrow. Okay, so I did work out a couple for you. Here's our sentence that summarizes independent practice, part A there. Not in a sentence, but there are the dimensions of this family room. And then lastly, we have the speed of our boat here. How long is it going to take? About 1 hour and 24 minutes to travel those 14 miles. So take a minute, jot those down. You can hit your pause button if you need to go back through some things. You can also look at the PDF file. If you need to jot a couple of notes down about those problems and say you missed one and you don't know what you did, you could go ahead and jot some things down. But that is our lesson, and then we'll catch up with this a little bit more tomorrow. Have a good night.